And now we write down the excitation table. Excitation table can be written, or the excitation table is the table which includes the current value, the current output, the past output, and the variable for which the flip-flop is taken. So we can write down the excitation table as excitation table. Let's take Q plus has two inputs. Let's take the different values 0 0 0 1 1 0 1 1, and we take as T. We find here the value of T, which is 0 1. Okay, so let's write down how to find out the excitation table. Excitation table can be worked out from the characteristic table. Let's say 0 0. When Q is 0 and Q plus is 0, what will be T? T here is 0, so we write it down as 0. When Q is 1 and Q plus is 1, so what the value for T is? 1 and 1. The value for T is 0, so we write down here as 0. Now when Q is 0 and Q plus is 1, so T is 1. That is, when Q is 0, Q plus is 1, then T is 1. When Q is 1 and Q plus is 0, that is, when Q is 1 here, Q plus is 0, Q is 1 and Q plus is 0, the value for T is 1. So we write it down here as, so the excitation table, characteristic table, this is the characteristic table, and this is the truth table. Henceforth we have covered the flip-flop topic, and now we can check out the applications of flip-flop, how the flip-flop can be used to manufacture or design the counters, and how they can be used to design different kind of circuits like synchronous counters, ripple counters, shift registers, and so on. Asynchronous input. What asynchronous input we can see? Let's study how we can work out the asynchronous input. What exactly is the meaning of asynchronous input? As we can see from the theory, SR, D and JK inputs are asynchronous inputs, as the data on these inputs are transferred to the flip-flop's output only on the triggered edge of the clocks. That is, asynchronous input is the input where the state of the flip-flop changes when the triggering of the clock changes. That is, when the clock changes from 1 to 0 or maybe 0 to 1, we can notice down the change in the state of the SR flip-flop or D flip-flop or JK flip-flop. So the states of these flip-flops are completely dependent on the state or the state of the change of the clocks. Asynchronous inputs affect the state of the flip-flop independent of the clock. Example: preset, pre and clear. Also, the asynchronous inputs can also be changed to the different input with the preset. Like, for example, I'll show you out with the circuit diagram. Let's say the circuit diagram for SR flip-flop. Asynchronous input. S, R, these are the inputs. Q, Q bar are the outputs. If we give a preset input here, preset, which we can see the bubble, it itself clears that it is a negative, it is a active low input, and the other input will be clear input. That is, if preset bar is selected, it will be giving the value as 0, since it is negative low input or active low input because of this bubble. If clear bar is selected, it will give 1 as input. That is, if this condition is selected, we get the output Q is equal to 1. That is, when preset bar is selected, to select the preset bar we have to give here value as 0, so that the clear bar which will not be selected. So if we don't want to select the clear bar, we give preset bar is equal to 0 and clear bar is equal to 1. That is, preset bar is equal to 0, so we get the output Q is equal to 1. That is, here preset is selected. Now if we give preset bar is equal to 1 and clear bar is equal to 0, here the flip-flop will be cleared. That is, clear here is a negative low or the active low input, and since we are giving 0 to clear, so clear will be selected and preset won't be selected. So in this case, the clear will be activated and the flip-flop will be cleared. That is, at the output of Q we will get Q is equal to 0, which is a set state, so which is a reset state, sorry. This can also be called as set, this can also be called as a reset or the clear value. So that is, it clears the flip-flop. So if we, okay, let's the other input is a clock. Since we are working with this preset and clear, no need for the flip-flop to work or to respond on the states of the clock. So we can draw the truth table for clock. Let's say clock preset PR bar in short form I'm writing, clear is CLR bar, and the output, that is Q. So let's say, since we are working with clock, that is when clock is not selected, when preset bar is 0 and clear bar is 1. That is, since the clock is not selected, the flip-flop will change its state as per the preset and clear inputs. So in this case, as we have worked out, preset bar is 0 and clear bar is 1. That is, the output for flip-flop will be 1. Similarly, if preset bar is given 1 and clear bar is 0, we can check out this 1 and 0, the output Q is 0. If preset bar is 0 and clear bar is 0, that is, again here the clock is not selected. That is, we cannot select these two inputs at the same time. Selecting preset bar and selecting clear bar at the same time won't allow, because either we have to select preset bar or either we have to select the clear bar. So we get the output as not allowed. That is, this operation is not allowed, as both preset bar and clear bar cannot be selected at the same time. Now when we have 1 1, that is 1 1 input can be selected, or preset bar and clear bar if not selected at the same time, this operation will be allowed, but in this case we have to give clock. That is, if we don't want to change the status of flip-flop, or if we don't want to change the state of the flip-flop using this preset bar and clear bar pin, we can deselect both clear and preset by giving 1 1. So if we have to change the state of the flip-flop by not selecting both of this, then in this case we have to make clock as high, so that the operation will be a normal operation.